Now, moment of inertia of the square ABCD about neutral axis, that is diagonal BD, is given by I1 is equal to moment of inertia of the two triangles ABD and BCD about their base BD. Very good thing over explain over here. Let us come to the tabletop. Here, this section is given to us. This is my diagonal BD. Now, this is the one triangle. This is the other triangle. We know that the moment of inertia of a triangle, if any triangle which has been given to us with the base B, height h, the moment of inertia about this x at base, that is 1 by 12 bh cube. This xx is nothing but the base, 1 by 12 bh cube. So, for this square section which is lying, whose one of the diagonal is vertical, in that case the I value about BD is equal to 2 times 1 by 12 bh cube, because this is the value for one rectangle. For another I have to multiply by twice. Please come to this PPT. Now, what is B? B is the base, and the base which has been given as 2a, referring the figure. This base which is given as 2a, and h is nothing but AC divided by 2. AC is of 2a, then this height is of 2a by 2, that is a. So, 2 into 2a into a cube by 12, and we achieve it as of a cube by 3. Now, Z1 is equal to I1 by Y maximum. Y maximum is nothing but the half of the diagonal. How? Let us refer the figure on this tabletop, as this is Y max. We know that I is equal to a raised to 4 by 3. Then Z is equal to I by Y max, and Y max is nothing but a. So, we can achieve on this PPT Z1 is equal to a cube by 3. Now, moment of resistance is given by M into M is equal to F into Z. So, by placing the value of Z1 over here, we can achieve moment of resistance M1 is equal to F into a cube by 3. This is our equation number 1, that is the moment of resistance obtained in the first case when one of the diagonal is vertical. Now, if we are referring to the figure B, moment of inertia of the new section with cutoff portion, that is the moment of inertia of D, E, F, B, H, G about the diagonal BD is given by the moment of inertia of the 4 triangles, and that 4 triangles are D, E, K, F, L, B, D, G, H and B, H, L, B, plus the moment of inertia of the rectangle EFGH about neutral axis. Please refer the figure in over here, please. The figure is over here, and let us be understood the things which has been stated over here. The total moment of inertia for this section is the moment of inertia of this triangle plus second triangle plus third triangle plus fourth triangle and about this rectangle, fifth one, about BD, the statement which is made over here. Now, that is 4 times bh cube by 12. Why 4 times? Because of 4 triangles. The moment of inertia of triangle about the base is bh cube by 12 plus moment of inertia of a rectangle is, it's one of the size b, another size is d, cube by 12. Here the intention is to find out that values over here. So if you refer EF into EG cube by 12, if you refer the figure, that is, what is this? EF, that is B. What is D? It is this D. EG or FH, it's cube by 12. Now, what is B and what is H for the triangles? For triangles, B is equal to H is equal to Y. If you refer it, please refer the figure. If you refer the figure is over here. This is Y. This is also Y. So if we come to this tabletop, let us be clearly understood what is the mix. So here, if we draw the in the tabletop, please, 2, 3, and the 4 sides are the 4. So we are making the flat portion. So we have to remove this one. We have to find out the moment of inertia about this axis. So 1, 2, 3, 4. Actually, this is not the scale. I will redraw once again to the scale so that you understood better way. Square section. We are making the flat top, flat bottom. To find out the moment of inertia, we divide into different parts. So if I will use another color pen, this is the first rectangle, this is the triangle 1, triangle 2, triangle 3, triangle 4. This is Y, this is Y. So we written as 1 by 12 Y into Y cube multiply by 4. So we came across this one. Now our intention is to find out this one, because this is my B and this is my H. See over here. Now, what is EF? EF is nothing but A minus Y twice A minus Y into bracket 2y cube divided by 12. So if you're referring over here on this tabletop, just see over here, we know that this is a on this tabletop, please, tabletop, this value is of 2a, this value is of 2a. Now this value is of 2y. So I am interested in this part. What is this part and what is this part? So we got this value as 2y. So when we write down for rectangle 1 by 12 BD cube, this D is 2y. Interested part is this B. I have to find out this distance. So what is this distance? 2a. And this distance y. So this distance we came across as 2a minus 2y is equal to 2 bracket a minus y. So if we referring the same thing over here on this PPT, we came across twice a minus y into 2y cube by 12, and hence by simplifying this we achieve as y raised to 4 by 3 plus 4 by 3 bracket a minus y into y cube, and once again simplify it, we achieve 4 by 3 a y cube minus y raised to 4. So now the section modulus of the new section is given by z2 is equal to I2 by y max. Y maximum right now is over here is with y. So we have I2 is 4 by 3 ay cube minus y raised to 4 divide by, and we achieve 4 by 3 ay square minus y cube. That is the section modulus of the another section. So moment of resistance is given by m is equal to f into z, that is z2, and we got it f into 4 by 3 ay square minus y cube. This is number 2. Now the moment of resistance of the new section will be maximum when the partial derivative of the moment with respect to the y is equal to 0, that is dm2 by dy is equal to 0, to find out the value of y. Hence differentiating the equation, that is number 2, with respect to y and equated with 0, means d by dy of this integration f bracket 4 by 3 ay square minus y cube, which is equated with 0. Now f over here is remaining constant, so the term comes out of the bracket. 4 by 3 is also constant for the first term. Y square, d by dy of y square is 2y, d by dy of y raised to cube, that is of 3y square, which is equated with 0. Once again simplifying this, we achieve 3y square is equal to 8 by 3 ay. Once again simplifying, we achieve y is equal to 8 by 9a. That we have to prove, that we have proved right now. What is the proving? That y is equal to 8a by 9. What it exactly means? Exactly means the central point to the top flat portion, the distance is y is equal to 8 by 9 times a, that is half of the diagonal. Then we can get the maximum bending stress, maximum moment of resistance. So substituting this value y in the above equation m2, because intention is to find out m2 maximum is equal to, by replacing the value of y which is related with the a. What is the a? Actually the twice a which has been given to us as the one of the diagonal. Hence if we are replacing over here, we can got it, the f is equal to 4 by 3a bracket 8a by 9 a square minus 8a by 9 a cube. Simplified it using your calculator, you can achieve f is f into 0.3512 a cube, 0.3512 a cube. It's number 4. Now from equation number 1, we achieve m1 is of 0.333 a cube, and here it is 0.3512. It means that definitely the moment of resistance increases, and its maximum value, which is absolutely achieved by topping, flattening top and the flattening bottom at a distance y is equal to 8 by 9a. I wish you have understood this problem very precisely, very clearly. Let us we go ahead with the next problem. Before the next problem, the remaining portion is how much percentage increase in the strength. That is, we can achieve by obtaining the ratio, that is increasing moment of resistance by original moment of resistance. What will be the increasing moment of resistance, which is given by m2 minus m1, that is 0.3512 a cube minus 0.333 a cube, that is increasing value is of 0.0179 a cube, divided by original, that is of 0.333 a cube. We achieve 5.37 percentage increase in the moment of resistance by flattening top and bottom at a distance of y is equal to 8 by 9a. Now refer the data. Prove that the ratio of depth to the width of the strongest beam that can be cut from a circular log of diameter d is 1.414. Hence, calculate the depth and the width of the strongest beam that can be cut of a cylindrical log of wood whose diameter is 300 mm. Let us first of all understood the data very precisely, very clearly, what the data which has been given to you and what we have to do exactly in this particular problem. In this problem, they stated one word, that circular log of wood. A wood is there whose cross section is circular. Now I have to cut from this circular portion, I have to make it as of the rectangular beam. Now we have to prove that depth to width of the strongest beam that can be cut from the circular log of diameter d is 1.414. That is depth to the width ratio, that is this b by this d ratio, depth to width means d by b ratio is of 1.414 to achieve the strongest section.